A'udhu billahi minash shaitanir rajeem. Bismillahir rahmanir rahim. Today we will discuss very important skill that how we convert binary number into hexadecimal number system. And you know that computer, electronics, and digital logic devices work very well with binary number system. But sometimes when we have very large stream of binary number and the human interaction is required, so this become very difficult to understand, to simplify, to calculate this binary stream. For example, when we are using memory system and we want to calculate the memory addresses, so we have to convert binary stream into hexadecimal in order to simplify the human interaction. For this purpose, it is very important to understand that by hexadecimal number system is a weighted number system, just like a binary, decimal, and octal binary number system. Its base is 16. 0 to 9 is the same, just like as a decimal, but after 9, 10 represented with a letter A, and 11 represent with B, 12 represents C, 13 represent D, and 14 represent E, and 15 represent F. The method to convert binary into hexadecimal is very simple. We have to group of binary into group of 4 bits, and we assign each of 4 bits with corresponding hexadecimal number system, and we total number system in the hexadecimal way we consider as a hexadecimal number. For example, we have a given a number 10110001. Now this is a binary string. We have to convert into 4 groups. We start from the right, 1001, it is a 1 group, and 101, it is a 3 bits, but no problem. Leftmost, you add a 0 in order to make a 4 bit. Now we have a two 4 bits, two 4 groups. For example, 1001 is a 1 group, and 0101 is another. Now look at the binary and hexadecimal table and find the corresponding hexadecimal number. When we compare 0101 and we observe that 0101 is equal to the 5 in hexadecimal, so we replace 0101 by 5. Now we take the another group which is 1001 and we again look into the hexadecimal table and we observe that 1001 is equal to the 9 in hexadecimal. So we replace this group by the 9. Up now this bit pattern, which is 011001, can be written in hexadecimal as a 5, 9. And each bit represents, each number in hexadecimal represents 4 bits. Now, it is very important to check that this number system is work very well or not. So we have to check the given calculation. It is very simple. You convert binary into decimal and hexadecimal into decimal. If both numbers are same, then it means that our algorithm work very well to convert binary number into hexadecimal number. For that purpose, we take this binary bit pattern 0 1 0 1 1 0 0 1, and again, as you have already learned this skill, that 1 multiplied by 2 power 6 and 0 multiplied by 2 power 5, 1 multiplied by 2 power 4, 1 multiplied by 2 power 3, 0 multiplied by 2 power 2, 0 multiplied by 2 power 1, and 1 multiplied by 2 power 0. Because we assign the weight for each bit here. Now, 2 power 6 is a 16, 2 power 5 is a 32, but 32 multiplied by 0 is 0. 2 power 4 is a 16. 16 multiplied by 1, we write 16. And 2 power 3 is 8. 8 multiplied by 1 is 8. And 2 power 2 is a 4. 4 multiplied by 0, 0. 2 power 1 is a 2. 2 multiplied by 0, 0. And 2 power 0 is 1. 1 multiplied by 1, 1. Now we add 16, 64, 16, 8 plus 1 is equal to the 89. Similarly, We again convert hexadecimal number into decimal, and our hexadecimal is a 59, where base is a 16. So we multiply it by, we start from 0 to 1, and we 5 multiplied by 16 power 1, and 9 multiplied by 16 power 0, and 16 power 1 is a 16, 16 multiplied by 5 is 80, and 16 power 0 is a 1, 1 multiplied by 9 is 9, so 80 plus 9 is 89. You will see that both from binary to decimal conversion and hexadecimal to decimal conversion is 89. So we can say that this binary pattern is represented by 59 in hexadecimal. Thank you.